So let's see another application of this. A man is bungee jumping from a tower that is 20 feet tall. He ends up falling from a tower at a rate of 2.5 feet every second. So we have a table here. It's time and height. We can actually build the table with just that very small amount of information. We know that the tower is 20 feet tall, so when time is 0, he should be 20 feet in the air. And then after 1 second, he falls a rate of 2.5 feet, so we would do 20 minus 2.5. That should get me 17.5. I can subtract 2.5 again. I'll get 15. I can subtract 2.5 again. I will get 12.5. So he's fallen 12.5 feet when all is said and done. Next part, I want to graph it on a table. So now I'm actually doing my graph properly. I'm going to label the titles. I have bungee jumping. I'll have time in seconds. I know it only goes up to 3, so I'm going to go ahead and just space it out by 1s on the bottom. Now the vertical axis, I'm going to do height in feet. That one, I'm going to go 5 up to 20. 5, 10, 15, 20, pretty simple from there. I'm going to plot my first point, 0, 20. Second point, 1, 17.5, so on and so forth till I have those 4 points. Last one being 3 and 12.5. And I could draw a line through them as well. We could test to see that it's linear, doing several different methods. Let's stick to the graphing method for this question. So those go through, those form a line. So now I can kind of talk about this idea of slope or average rate of change. So I can identify the slope. I'm going to use that formula. I wouldn't say you would have to memorize it. It'll be valuable because it'll come up a lot, but I believe it's on the test. If not, I'll give it to you when you take the test. And that is, again, y2 minus y1 over x2 minus x1. So I'm going to, let's go ahead and identify the 2 points I picked. So since this is a line, as we talked about at the very beginning of this section, the average rate of change should be the same no matter what. So you can pick any 2 points to find your slope. It should be the same. I'm going to pick 215, that's a whole number, and 020, that is also a whole number, just to avoid decimals. But you could pick any of them and it should still work. So I made my y2 15, my y1 20, my x2 2, my x1 0. I go ahead and plug it into my formula. I subtract, I get negative 15 over 2. And then this idea of talking about slope, we don't want to lose sight of what it actually means. So we went through an application problem in the last slide, and we went through this one to kind of talk about what is slope. What is slope in the real world? Well, I have my slope of negative 5 over 2. I use my formula. It's easy to lose sight of what we're talking about, but we're talking about a guy falling, and we're talking about relative change. So when we're going to interpret our slope, we're going to have to talk about the change in rise over the change in run. So with that in mind, we have our slope is negative 5 over 2, so that means that my jumper is falling 5 feet every 2 seconds, or I kind of flip the order of the sentence. The sentiment is still the same. Every 2 seconds, the bungee jumper falls 2 feet, because we're talking about that average range of change, the change in output over the change in input. He fell 5 feet every 2 seconds. If you've printed out the worksheet ahead of time, you're kind of following along and you've gotten a few slides in at this point, you might be thinking, oh, usually by slide 3 or by slide 4, we've had a problem. You haven't had a problem yet on the worksheet because a lot of it is we're building into concepts that will actually cover what we've talked about. So I'm not going to make you find slope and then later on we're going to find slope and then do something with it. So we're going to apply it all together. But this is the first part that's kind of a standalone individual thing. We're going to talk about horizontal and vertical intercepts, so I believe that's going to be the first 3 on the worksheet. So you might want to go ahead and print it out or pull it out if you don't have that already. So horizontal intercept, by definition, is the point where the graph touches or crosses the horizontal and typically x-axis. So I kind of did back and forth there because if we're talking about applications problems, we don't know it's necessarily x. So it is a horizontal intercept. But if it's a mathematical problem, it's the x-axis. Same thing with that vertical. Vertical is the y-intercept if we're doing just a strictly math problem, but if we're doing an application problem, it's the point where the graph touches or crosses the vertical axis. So example 7 has us just very basically talking about what that would look like on this graph. So in this graph, we have a line that's going through both axes, the vertical and horizontal axis. So by definition, the horizontal easily enough is that point in the bottom right where it's crossing the axis. So counting over 1, 2, 3, 4, 5, 6, 7, that point is 7, 0. And then same idea when we're doing the vertical intercept, that circle as a red circle on the top left of the graph, that is 1, 2, 3, 4, 5 up, so 0, 5. So that's the very basics of what a horizontal and vertical intercept is. So now let's look at what that actually is in a question, what we could see what that would look like, because that'd be a little bit silly to be on the test because you would just point and you'd be done. It is valuable to know what you're talking about, but there isn't a whole lot of math behind it. Where these questions, we can find our slope and our intercepts from an equation. So we have an equation right here, 6x plus 4y is equal to 12. Well, let's start by finding our intercepts. So the way to do it is, you may have noticed in the previous section that when you're finding the horizontal intercept, the y is always going to be 0. So to find that in this question, we say y is equal to 0, solve for x. So I plug in 0 for y, solve for x. Well, 6x equals 12, divide both sides by 6. I'll get x is equal to 2, eventually. There we go. Now, that's not the answer. That is what you did in algebra, and yes, you solve for x, but that's not a point. An intercept is a point. So in order for you to get full credit on this question when it shows up on the test, if it shows up on the test, is by writing it as a point, 2, 0, because we said y is equal to 0. So that's our horizontal intercept. Similarly, vertical intercept is, in this case, we're setting x equal to 0 and solving for y. So 6 times 0 is 0, that goes away, leaving me with 4y is equal to 12. Divide both sides by 4, I get y is equal to 3. Again, that's not a point. That is what y is, but that is not a point. A point would be 0, 3. That's my vertical intercept. Now, slope, well, we have 2 points there. My first point is 2, 0. My second point is 0, 3. So if I do rise over run, I would have 3 minus 0 over 0 minus 2. Again, that's that formula that we've seen before. I subtract the 2, I'm left with 3 is equal to negative 2. Now, let's say that we're given a point 3, negative 2. We want to find 2 more points on that line. Well, I would plot that line. It's a vertical line, so I'm going to go ahead and draw a vertical line through that point. And then, easily enough, I'm just going to pick 2 more points on that line. You might not get these exact answers, but because there's a ton of different answers. But the important thing is that x is going to always be 3. So that's our equation. X is 3 feels weird, but that's our equation. X is 3. And then I'm just picked this point 3, 0. And let's see, let's pick this other point. I believe that's up 5, so 3, 5. The important thing is that x is always going to be 3. So the equation is x equals 3. The 2 additional points are 3, 0 and 3, 5. Now, we want to find a horizontal line through the point 3, negative 2. So again, we're plotting that point 3, negative 2. We're drawing a line that's horizontal that goes through that point. Now, if I want to find 2 more points on that line, but the equation in this case is y is equal to negative 2. So if it's a horizontal line, we're going to have y is equal to something. If it's a vertical line, we're going to have x is equal to something for the equation. And then 2 more points, again, you can pick anything. I think I picked there, poorly drawn circle, but 3, negative 2, or negative 3, negative 2, perfect. And then I picked another one, 6, negative 2. Again, it doesn't really matter as long as that y value is negative 2. Any values of x will work for that those 2 points. Slide.